This video is over lessons 48 through 50. Lesson 48, Subtracting Mixed Numbers with Regrouping Part 1. Lesson 49, Dividing by a Decimal Number. And Lesson 50, Decimal Number Line Tenths and Dividing by a Fraction. Take a moment to copy this title into your notes. When you're ready, hit play again. Moving on in 3, 2, 1. In earlier videos we've already done subtracting mixed numbers. However, we're still going to review it here. So let's say we have 8 and 2/5, and we're subtracting 6 and 3/5. Well, obviously the problem is if you have 2/5, how can we take away 3/5? And just like any other subtraction problem, when you can't subtract, we look to something larger to borrow from. So we're going to borrow from the 8, and we're going to make it a 7. And here's where we need to do a little bit of thinking. So we have borrowed 1. To go from 8 down to 7 is 1. Now we're going to take that 1 and put it on to the fraction. So what we're basically saying is we're going to take this 1 and change it into fifths so we can combine it with the 2/5. So 1 is how many fifths? Well, what would 1 be as a form of 1 with 5 as the denominator? Well, it'd be 5/5. So that means I'm going to take this 1 that I'm borrowing here, which is worth 5/5, and add it to my 2/5. Well, 2 and 5 makes 7. And the 7's here are just a coincidence. They're not always going to match. They just did in this problem. That's all. And now we're ready to subtract. 7/5 minus 3/5 is 4/5. And 7 minus 6 is 1. So the difference is 1 and 4/5. Let's try another example now. Let's do 9 and 3/8 minus 2 and 5/8. Once again, we can't subtract our fractions. If you've only got 3, how can you take away 5? So we need to look to the whole numbers to borrow. So I'm going to borrow 1 off of my 9, making it an 8. And again, we need to do some thinking here. So we borrowed 1 whole, but this time we're going to combine that 1 whole with this 3/8. So what would 1 be in eighths? Well, what form of 1 has 8 as a denominator? Well, 8/8. So the 1 that we borrowed, which is worth 8/8, is going to combine with the 3/8 that's already there. Well, 8 and 3 makes 11. Now we're ready to subtract. 11/8 minus 5/8 is 6/8. And 8 minus 2 is 6. Now whenever we have fractions and mixed numbers, we always need to check to see if we can reduce. Over here, 4/5 we couldn't, but here 2 goes into 6 and 2 goes into 8. So we can reduce by 2/2. So whole number comes over. 6 divided by 2 is 3. 8 divided by 2 is 4. 3 and 4 cannot be reduced, so therefore 6 3/4 is my final answer. Moving on in 3, 2, 1. The key to dividing by a decimal is to create an equivalent division problem. And in order to create an equivalent division problem, we have to multiply or divide both numbers, so in other words, the dividend and the divisor, by the same amount. So for example, let's say we had 5.34 and we divide that by 0.8. Well, in a previous video, we learned that we can divide decimals by whole numbers fairly simply. So if we can just turn this into a whole number, then this problem should become quite easy. So, if I want to turn 0.8 into a whole number, the easiest way to do that is to multiply it by a power of 10, so the decimal will move over, making it a whole number. Well, since I just need the decimal to move once, I'm going to take this and multiply by 10. But remember, we have to do the same thing to both of these. So that means I've got to multiply this number by 10 as well. And so my new problem, if I move the decimal over there once, is going to be 53.4 divided by, and then the decimal here will move over once, 8. But the way we set this up is going to be a little bit simpler than that. We're going to put it in a division box. 5.34 is the first number, so it goes in. And 0.8 being the second number goes out. And now I'm just going to move the decimal. So multiply that by 10, moves it over once. I've got to do the same thing to the dividend. Multiply by 10, it moves it over once. And there it is. And so all of this is right here. And this is how we're going to show our work. Let's go ahead and finish this off now. Now that we've got our 8, we're just going to divide into this now. First step though, don't forget to bring up the decimal. And now we're ready to divide. 8 does not go into 5, and so that's 0. 8 does go into 53, 6 times, because 6 times 8 is 48. Do some subtracting here, got to do some borrowing, so that becomes a 4, that becomes a 13. 13 minus 8 then is 5, and 4 minus 4 is 0. Bring down the next digit, 4. 8 goes into 54, 6 times again. 6 times 8 is still 48. And if you realize that 48 is 8 times 6 and 54 is 9 times 6, you should be able to tell pretty quickly that the difference here is going to be 6. If not, go ahead and do your borrowing and you'll see it. Now, I've run out of things, but remember we have to commit. If I'm going decimals, I have to keep going with decimals. I can't switch over to fractions, and I certainly can't just take this remainder and stick it up here. So I need to bring something else down. So the question is, what would come down? So what is in this space? Well, it's an invisible 0. So bring it down. 8 goes into 60 7 times. 7 times 8 is 56. Subtract, we get 4. Again, I need something to bring down. Well, this empty space really has a 0. So we're going to bring down that 0. 8 goes evenly into 40 5 times. And so the answer is 6.675. Moving on in 3, 2, 1. Dividing by a number is the same as multiplying by its reciprocal. Take a moment and copy that down. Now let's take one color and underline this. Dividing by a number. Well, dividing by a number is the same as multiplying by its reciprocal. So let's take a look at an example. Let's say we have 2/5 divided by 1/3. Well, dividing by a number. So what are we dividing by here? Well, we're dividing by 1/3. So that must be the same as multiplying by its reciprocal. So dividing by 1/3 must be the same as multiplying by its reciprocal. So 3/1. Notice that nothing happened to the 2/5, and so it just gets copied down. Now I have a multiplication problem, which with fractions multiplication problems are very easy. We just multiply across. So 2 times 3 is 6, 5 times 1 is 5, and then we just need to check to see if we can reduce. We can't reduce. We also need to check to see if we can change this into a mixed number. This time we can. 5 does go into 6. 1 full time with 1/5 left over. And so the answer, 1 1/5. Let's try another example. 3/4 divided by 2/3. Once again, we need to think about what are we dividing by. So dividing by a number. This time, we're dividing by 2/3. So that must be the same as multiplying by its reciprocal, which is 3/2. So 3/4 divided by 2/3 is the same as 3/4 times 3/2. Now we're ready to multiply. 3 times 3 is 9. 4 times 2 is 8. Simplify that. 8 goes into 9 once, with 1 left over. So 1 and 1/8. Quick note here. Notice that 3 and 3 can be reduced. 2 and 4 can be reduced. But I didn't reduce these. We can only reduce before multiplying. So if you had reduced this 3 and this 3, it would have been a big error, which we can see once it switches over to multiplication, that the 3's and the 3's obviously don't cancel. The 2 and the 4 obviously don't cancel. So remember, reducing only works before multiplying, not before dividing. Moving on in 3, 2, 1. For the decimal number line, please create a number line where to go from 0 to 1, we have to move up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tick marks in order to get up to 1 from 0. Now since it takes 10 jumps to get up to 1, that means that each one of these tick marks is worth a tenth. So we could write each of their values like this. But since we have fractions, we would have to do some reducing with several of these. But since each of these is a tenth, and decimals really are special numbers where the denominators are powers of 10, so tenths, hundredths, thousandths, 10,000ths, and so on. Another way that I could label this is by using my decimal places, which would look like this. So we can see here 1/10 is the same as 0.1. 2/10 the same as 0.2. 3/10 0.3, and so on and so on and so on and so on and so on. Most of the time, if a number line is broken down into tenths, use decimals. They're just a little bit simpler when it's broken down into tenths. This video ends in 3, 2, 1.